Okay, good afternoon. Let us start today's session. Uh, am I audible to everyone? Am I audible?
Yes, sir.
Okay,
Yes,
yeah,
sir.
fine, thank you. In yesterday's session, we had discussed about some programming features, and in that we had discussed about the word address format. So we had discussed that each word, then a word consists of a block, and block consists of a entire line. Okay, so that this is the sequence. Each block is composed of several instructions, and those instructions are called as words. So these are the words. It's a alphanumeric combination, alphanumeric characters, which are called as word, and this is a sequence and format of the word. So remember, we are using the word address format for CNC. Okay, so this format that we are using is called as word address format. There are many formats through which the CNC program can be written, but specifically we are using word address format. And one more thing you must remember, that we are following the FANUC controllers instructions. As I told you earlier, there are several controllers based on the manufacturers. We are following the FANUC controllers formats. So there is a little bit difference between each controller depending upon the manufacturer, but we are strictly adhering to that because it is mentioned in the syllabus. So just take a quick recap. This is N indicates sequence number, G indicates preparatory functions starting from G00 to G99. In yesterday's session, we had discussed few important G codes. X, Y, Z are the destination coordinates. I, J, K are the distance from the center of circle. This I, J, K will be going to discuss in today's lecture. Then F stands for feed rate, S stands for spindle speed, T stands for tool, and M stands for miscellaneous functions. So this is a sequence and format of the blocks. This sequence must be followed strictly. You cannot write M over here, or you cannot write X over here. Okay, so there must be a sequence number, then preparatory code, then destination coordinates, then distance to centers, then feed speed, and the tool, and then miscellaneous function. So this format must be followed. Now let us again going into detail of the word address format and various functions. So G92, it's a code, preparatory code, which is used for the absolute preset. Now what is absolute preset? It is used to show the current tool position with respect to 0 at the time of starting the machine. Okay, it shows the current tool position with respect to 0. So once the cutter is positioned, defining G92, machine will draw its coordinate system. At that point, let us say tool is at some point over here. So tool is somewhere over here. So this at that point of time, you write this code G92. So this will be your, what we can say, it will be your 0 position. So this will be your 0 position for the that particular workpiece, and the machine will draw its coordinate system considering this point as a 0. So you have to place your tool at one position, and that position, if you write G92, that position will be considered as a 0 position with respect to starting at the time of starting of the machine. Once you define G92, you need not to define G90. Now recall, G90 is the code for absolute positioning system, in which we define each and every point with respect to some fixed origin. So once you define G92, this point will be your fixed origin, and every point that you will be placing on the tool, and you will be moving your tool at that particular point, is calculated with respect to this zero point, irrespective of whatever your fixed zero and floating zero for the machine. Okay, so that is what we call as absolute preset G92. Then we had discussed yesterday reference point and return point. I told you I will discuss it later on. So what is reference point and return point? These things are important. Uh, these reference point and return points are mostly important in your when you deal with your CAN cycles. Okay, specifically drilling CAN cycle. So G28, return to reference point. It is the set. It is a set point, optional intermediate point. So this is uh, an optional intermediate point, not a zero point, which is defined on the machine. So G28 code is used to return to the machine zero position on all axes. Okay, if XYZ or A axis is on the same block and specifies the location, only those axes will move and return to the machine zero reference point, and the movement to the all machine zero reference point will be through that specified position. Okay, so let us say this machine is drilling on this machine table. Fine. Now we will position one certain reference point over here. Okay, at particular distance, and we mark that that reference point as a zero point for for some time. Let us say the actual zero located somewhere over here, but we don't want our spindle to move that much far distance. We want it to somewhere nearer to the workpiece. Okay, that's why this intermediate point or reference point is defined, and G28 code is for defining that reference point, or calling the machine to the reference point. Now let me tell you why this Z0 or intermediate reference point is used. Now consider this is an entire workpiece. You have to drill the number of holes. Okay, number of holes over here. So you will be drilling one hole. Okay, and after that you will be retracting your machine, retracting the tool, and taking it upward up to certain location. Then you will be moving to another point. Again your machine will start drilling. Again the tool will go retracting, and again you'll go to the third point. Now what happens if we every time used to call this tool at the machine zero position, which the manufacturer has referred, or the fixed zero position? Then what happens, the tool will take a lot of time to travel from this surface of the part to your fixed zero position. Now that much time if we want to save, then what we'll do, the programmer fixes some reference point. It is a an intermediate or some temporary reference point. Oh, it's called is at a zero point, reference point. So the machine tool, the tool will retracted and returns to at certain location, zero point. So the machine need not to travel up to fixed zero. So traveling from this point to this point, this much distance travel, the time taken to travel for this distance will uh, be saved. That is why we locate the reference point. Once we start our CAN cycle, you will come to know why these reference points are used. So but you remember G28 is for the return to the reference point. Now, G54 to 59 are the coordinates used for the work coordinate system selection. So this is entire machine table, and if you are using small parts, and if you are placing at number of different location on the same machine table, then there is a system which facilitates you to setting the working coordinate system. So for example, G for 54 is for selecting work coordinate system 1. So where is work coordinate system one? So this is your work coordinate system. So you have placed one part over here. So your machine will select this work coordinate system and perform the or the execute the program accordingly. Then your second part is over here. Then in the next part of the program, the instruction will be given that G55. Now the machine has to move on the G55 work coordinate. So it will move over here. So it will uh, machine this part. Then again it will move to G56, the third part, then fourth part. The parts are similar in nature, but you have to, or the machine has to work one after the other, okay, without removing this part, because these parts are fixed into the fixtures, and the number of parts we need to machine one after the other without removing them or without stopping the machine. That's why those parts are located at different work coordinate system, and this G54 to G59 are the different work coordinate system selection codes. So it first is select this coordinate system. Once this part is done, the machine will move to the second coordinate system with the G55, and it will again rerun the program, then moves to third one, fourth one, sixth one, likewise the programming will happen. So the advantage is you need not to stop the machine, you need not to remove the one part and place the other part. Multiple parts, small number of parts are placed, and one after the other the machine will start its processing or machining operation. So that is what we call work coordinate system. Now pictorially it is represented G00 rapid travels. As I said, we are interested in only in the cutting motion. So whatever the non-cutting motion is there, we want to either remove it, or we are intended to uh, make it the time as small as possible. So when the tool is positioned at a point preparatory to the cutting motion, to save the time, it is move along a straight line at rapid travels at a fixed travel rate, which is pre-programmed into machine's control system. Okay, typical rapid travels rate is 10 to 25 meters per minute. It can be as high as 80 meters per minute. So what we want, our tool is positioned at this point and it is moving up to this point, and from this point the cutter is starting, or the tool is start rotating. So from moving from this point to this point, there is no cutting action involved. So this is a non-cutting time, non-productive time. So we want to minimize this time as less as possible. So that's why our intention is to move this cutter as fast as possible to the cutting motion. So that's why G00 rapid travels is used, and uh, the tool moves in a rapid direction. So the only one intention is to save the time, save the non-productive time. Then G01 is the linear interpolation. It is feet travels when the tool moves along a straight line in one or two axes simultaneously at a programmed linear speed. So this is the format: block number G01, X, Y, Z, your coordinates for the various axes, and a feed rate. You have to specify the feed rate. Now you have to specify the feed rate depending upon which part you are using and how much material you want to remove. So either it is traveling along one axis or two axes simultaneously. So G01 is for linear interpolation. It is used for feed travels. Then G02 and G03 are used for circular interpolation. So G02 is circular interpolation when the tool is moving along a circular direction along an arc in clockwise direction. Then we are using the code G02. From this point to this point, if the cutter is moving, then we use the circular interpolation code G02. When it is moving in counterclockwise direction, we use the G03 code, which is circular interpolation counterclockwise. Now we have discussed few things like IJK. So what is this IJK like, or XYZ RF or F? So for circular interpolation, whenever the cutter moves from start point of the arc and it is end point of the arc, it is moving either clockwise or counterclockwise direction. There are two methods to define how much distance it should travel. What I mean to say is, this is the start point of the arc and this is the end point of the arc. After this point, the cutter uh, travels in a linear motion. So we need to define how much is this circular portion. How much is this circular portion? So that for that much of portion only, the cutter or the tool will follow the circular motion, circular interpolation. So for that there are two methods. One is arc center method and second one is the arc radius method. So G02 moves the arc or the cutter along counterclockwise arc, clockwise arc, and G02 moves along counterclockwise arc. Now arc center method. How it start? The arc center specifies by the addresses IJK. Now you come to know what is IJK. So this is start point of the arc and it is arc end point. This is end point of the arc. Now you can guess that the this is counterclockwise motion. That means we are using the code G02. Now we have to define the coordinates IJK. Okay, so what is I coordinate? I coordinates is the distance from start of the arc, the point at which the arc is starting, to the center of the arc. This is center of the arc. So this much is the distance, is called as I distance. And it is why it is mentioned in minus sign, because it is moving towards left. So by the sign convention, it is considered as minus. And what is J distance? The J distance is the distance of the start point of the arc and towards the center, up to the center of the arc. So this is start point of the arc and this is center of the arc. So this distance is J. Again, why minus? Because this is going into the negative direction. That's why it is minus. Now, what is I? I is the x coordinate of center, x coordinate of the start point of the arc. So in conventional form, if you look this graph, this is your x coordinate, this is your x axis, but we are differentiating with the letters ijk from our principal axis. So that's why we have denoted it by I. So what is I distance? It is a x coordinate or distance along x coordinate from start point of the arc towards the center. And what is this J? This is center of the arc, distance of the start point of the arc to the center of the arc along y direction. And k is the along z direction, but we don't need k in most of the time. So ijk must be written with their sign. So why ijk must be written with their sign? Now consider another situation, like the arc is we are using G02. Now this is start point of the arc and this is end point of the arc. Now we have to calculate the I and J distances. So this is what is I distance? From start point of the arc to the center of the arc along y direction. So this might be the distance. This is the distance. Let me draw this. I'll try to draw. So this is your distance from this point to the center of the arc. Now you are moving from left to right. So you will be writing plus I. What you will be writing? You will be writing plus I, because you are starting from this point and moving towards center of the arc, from moving left to right. So that's why it is plus I. And for J, what is J? It is y coordinate of the center, y coordinate from the start point. So from this start point to the center of the arc. Now it is moving minus or negative direction or downward direction. So you will be writing minus J. Okay, so that's why it is written, the signs IJK must be written with their sign. So those signs are very, very important. Let me tell you once again, what is this IJ? Your start point of the arc, that you need to consider. Okay, it is not an end point. It is a start point of the arc. For I, you have to move along x direction and you have to calculate how much the distance is from the start point of the arc to the center of the arc. That you have to calculate. And depending upon in which direction you are traveling to calculate that distance. Based on that, your sign will be dependent upon. Okay, so that is what we call as arc center method. And another one is your arc radius method, which is very very easy. You have to just write the radius of the arc. You have to just write the radius, how much is the radius. So if from this point to this point the radius is let us say 5 millimeters, so you simply write 5 over here. So that is your arc radius method. Now in exam they might have specifically tell you have to use arc center method. So you cannot write this r, or you cannot use arc radius method. You have to follow this sign convention ijk. So that is that these are the few things you need to remember when we talk about the circular interpolation. The first thing is G02 is the circular interpolation clockwise. G03 excuse me, G03 is the circular interpolation counterclockwise. There are two methods for circular interpolation, irrespective of clockwise or counterclockwise rotation. First is arc center method, in which you have to make a use of I and J and K coordinates, where I is X coordinate of the center from start point of the arc to the center of the arc, and J is the this y coordinate of the center from start point of the arc to the center of the arc. They should be given along, they should be written along with their signs. And in arc radius method, you have to directly write the radius. So this is arc radius method. This is your arc radius. You simply write the arc radius irrespective of whether the arc is from where the arc is starting or ending. Now next command is dwell command. Yesterday we talked something about this dwell command. So G04 is used for the dwell command. So G04 dwell is used for the execution of the next block is delayed by a specified time. Specified dwell for each rotation in feed per rotation mode. Dwell is used to stop feed for specified period of time. So whenever you are writing this G04 in front of the block, it will stop or it will delay the execution of the block. Like here you are writing G04. So for X, that means your tool movement will stop for particular duration of time. G04F, if you write in front of feed, so your feed will remain delayed for a particular time. G04P, so this is for thread cutting. So your thread cutting will stop for particular, or it is delayed for some particular amount of time. So what is the use of dwell command? It is kind of pause command, as I discussed earlier. It is a kind of pause command. The execution of the next block will be delayed by the specified time. Like over here, G04 X15. Okay, so it is mentioned over here. So here the machine is dwell for the 15 seconds. 15 seconds. So X coordinate distance, whether it is moving for X coordinate, so that is delayed for the 15 second. G04 feed is delayed for 15 second, and P 5000, so it will be delayed for particular 5 seconds. So this will discuss sorry, 15 seconds. So we'll discuss this when we discuss the thread cutting operation. So hence here the machine is dwell for 15 seconds. So machine will stop for 15 seconds for either for going for X direction, or feed will be stopped, or thread cutting will be delayed for that particular duration. The function is non-modal. Non-modal means it will remain for or this command will be remain activated only for the execution of particular block. Once that block is executed, the command will deactivate it. So that's why it is not modal. So it can be used in boring, making cam profile. At this point, dwell is required. So when we get a particular pause for a specified time, the operator will come to know, or he may check whether the particular operation is carried out uh, conveniently or correctly or not. So that's why this G04 dwell command is used. Now G15 and G16, these are used for the polar coordinates. So again, these are the modal commands, but we don't need G15 and G16 commands. Just you, for the sake of information, you remember G15 and G16 are for polar coordinate. Now G17, 18 and 19 are used for the selection of the planes. So use the parameters to appropriate circumrotate axis in X, Y, or Z, or these axes that are parallel to the axis. So G17, G18, and G19. If we want to select the different planes parallel to X, Y, and Z plane, so that can be used for if you want to select those planes, then these G70, 18, 19 can be used. Then G20 and G21. G20 is for inch command, inch mode, and G21 is for metric mode. So we don't need G20 most of the time since we follow metric mode. So we will be most of the time using G21. But this is a preparatory command. You have to use G21. So it's a selection is meaningful only for linear axis and it's meaningful for rotary axis. The input unit for G20 and G21 will not change just by changing the command unit. Okay, once you give this input command, it is a modal command, it will remain active unless and until you change it. So in other words, if the machining program command unit changes to an inch unit at G22 when its initial inch is off, the setting unit of the tool offset amount will remain metric. So setting value you need to take care of, but we need not to go into that much of detail. Just at the preparatory phases you have to write G21. Now what is radius compensation? So yesterday I told you G40, 41 and 42. So tool radius compensation cancel, compensation right and compensation left. So what happens? Now let us consider G41 type of situation. Now this is your workpiece. You have to cut this workpiece. I mean, you have to mill this workpiece profile. So outer profile that needs to be milled. This is your center of the cutter. This is the center of the cutter. The system or the machine usually follows the path specified, or it is passing through the center of the cutter. Okay, let us say the radius of the cutter is 5. The radius of the cutter is 5 millimeter. Okay, and you don't give this command, or you forget to write G41 command. So what happens? Your cutter, the center of this cutter will now shifted to this position. Okay, and your cutter will be positioned something like this. Fine. So what happens because of this? Your cutter will follow this path. It is expected to follow this path, but it is following this path now. Okay, and because of that, your 5 millimeter distance, or this job is 5 millimeters overcut because the radius of the cutter is 5 millimeter. Okay, so your part will be, now it will be look like something like this. This will be your part. You don't want this much is overcut portion. Whatever the portions are over here, these are the overcut portion. So you don't want this to be happen. Okay, so what you will do, you will say you will use the G41 command. So tool knows radius compensation left. Now because of this command, what happens? If you are using a tool, let us say you are using tool 01, tool 1, let us say. So it is program memory, it is mentioned that for tool 1, the mill cutter, it is a milling cutter, and its radius is 5 millimeter. Its radius is 5 millimeter. So whenever you select that tool and you use this G41 command, the tool will be offsetted towards left by a distance equal to radius of the cutter. So automatically, instead of this position, the tool will itself move to 5 millimeters left. It will offset its center 5 millimeters to the left, so that it will follow this path. So that it will follow this path like this. Okay, and because of that, your object will be cut in very smooth manner. Fine. Also, G41 over here. So again, for internal cutting, if it is moving like this, again it is moving towards left. If you have to cut the internal profile, so instead of this point, it will move towards left like this up to this point by 5 millimeter distance, and it will cut the internal profile. So that is why G41 is used. Now G42. Now the cutter is traveling in counterclockwise direction. Same thing. If you don't use this cutter compensation towards right, what happens? This center is now shifting to over here. Your then your cutter will be like this, and this much of portion is overcut. So this much of portion is overcut. So for that, what you need to solve this problem, if your cutter is traveling in counterclockwise direction, you need to shift the center of the cutter to the right by a distance equal to the radius of the cutter. So for that, you will be using G42, tool node radius compensation to the right. Same is for internal internal cutting, profile cutting, okay, or milling. So that is why G41 and G42 are used. Again, these are the modal commands. Once these will remain active till you cancel it with the command G40. Okay, so at the start of the program, you have to write this G40 code, because some of the programmer might have forget to cancel it in its previous program. So you have to take care that at the start of the program, you cancel all the previous commands, all the previous modal commands which are active, which may be active in the last program that is executed. So this is cutter compensation, cutter radius compensation. Now subroutine. As I told you earlier, subroutine or the subprogram, it's a separate program called up by another program. So it is a separate program, and it is called in between your main program. The use of subprogram can significantly reduce the amount of programming on some part. It significantly reduce the amount of programming, or it significantly reduce the length of the program. Okay, so when you have to follow some repetitive task, like I have to drill 5 holes at a particular location in the particular workpiece, so you write a small program, sub program we call it, or subroutine we call it, in and you call that subroutine in between your program. So that much, instead of writing that small program every time, it can be called from the separate location. So that's why the length of the program, the main program, is significantly reduced. So subroutines allow the CNC programmer to define a series of commands which might be repeated several times in a program. So these are the this is the advantage. If there are commands which might be repeated in several times in the program, so subroutines, instead of repeating those commands every time, you can call a subroutine. Instead of repeating them many lines, they can be called up when needed. So these commands are stored, or these subroutines are stored somewhere in the computer memory or programmer controller memory, and as and when needed, they are called up. So that's why you need not to enter, or you need not to mention every time those commands in your main program. A subroutine call is done with M98 or PNNN. So PNNN means here you have to write the subroutine number. Okay. M98 is for calling the subroutine, and which subroutine has to call, or subroutine subprogram has to call. So it is mentioned with the help of P. Let us say P1000. So P1000 numbered subprogram is called with the M98 command. The P code commands identified the O program number being used when executed with M98. So this it must be M98, and this program number must be executed at the same time, so that M98 is the command to understand the controller that you are calling a subprogram, and which subprogram or subroutine you are calling, the P1000 number subprogram you are calling. M99 ends the subprogram. Since we are needing M98, you can guess now M98 is the modal command. You have to cancel the modal command with M99. So M99 ends the subprogram and returns back to the next line in the main program. Okay, so let us say these are the lines of the main program, and from this line you are calling your subprogram. So subprogram is like this. So this is your subprogram, and once this subprogram is called end, you give the command M99. So your controller will jumps to the next line of the main program. Okay, so this number of subroutines or subprogram you can include uh, in your main program. Now if you consider that this subroutine or subprogram is having 10 number of blocks, so instead of writing 10 blocks every time, you can call this subprogram. You can form the subprogram or subroutine and call that subprogram as and when needed. So you will, this length of the program will be drastically reduced, and the program will save its time. So that is the function of subroutine. In exam, most of the time they ask you explain the subroutine and what is the use of subroutine. So at that time you should be able to explain these things. Now G42, tool length compensation. What is tool length compensation? You might be knowing that we use different tools having different lengths in the same part, like shown over here. So this is face milling cutter, this is boring tool, back boring tool. So each tool is having some different length. So these are the length offsets for all these tools. So different tools of different lengths are used in machining any part. The lengths of the tools are not considered in the part program. Okay, so we, in the program that we are writing, we are not considering this program the length of the tool. Okay, so they entered into the machine memory. Where these lengths are entered, the lengths are entered in the machine memory. So every geometrical data related to tool is entered into the machine memory. Our task is just to call that particular tool. Okay, they are entered into machine's memory and considered automatically for each motion in the program depending on the tool that is being used. So that length offset will be automatically called when that particular tool is called. So the tool lengths in Z direction are called the tool length offset. The tool lengths along Z direction. Now you must be able to identify this is the Z direction because it is aligning with the spindle or the power cutter motion. Okay, so G42, G43. So make the value of cutter offset add to the value of Z coordinate of the program. So what is G43? It make the value of the cutter offset to add to the value of Z coordinate of the program. Okay, so if we are using this tool and your Z coordinate or some reference point is over here, so you have to add this much of value, this much of distance to the value of Z coordinate of the program if the tool is short. G43, make the value of cutter's offset subtract the value of Z coordinate of the program. So if the tool is long and your Z value is like this, so you have to subtract the value of cutter offset to the value of Z coordinate of the program. Again, these G43 and 44 are your what you can say the modal commands, and G49 is used for the cancel of the cutter, cancel of the tool radius, the tool length compensation. Okay, so this is tool length offset. This is tool length offset H01. If you are adding this value, so this is adding addition of the value. If your tool is short, if your tool is long, you will be subtracting this value. Okay, so that is what we call tool length compensation, G43 and 44. Now canned cycle. What is meaning of canned cycle? Canned cycles, these are also called as fixed cycles, are programming aids that simplify the programming. Canned cycles combine many programming operations and are designed to shorten the program length. Similar to that of your subroutines, the canned cycle combine many programming operation, and they are used to shorten the programming length, minimize mathematical calculations, and use minimum tool motion. This is very, very important. Minimal tool motion means the unnecessary motion or unproductive uncutting motion of the tool are avoided with the help of can cycles. So these are the advantages of can cycle. What are the advantages? It reduces the program length. It minimizes the mathematical calculation. It minimizes the tool motions. Okay, so that is the use of can cycle. So examples are drilling, peg drilling, tapping, boring, backspot, facing, etc. So G81 is for drilling cycle. 82 drilling cycle with dwell. Now dwell means you are pausing for a particular amount of time. Counter bore cycle, in which you will be rotating, reversing the direction. G83 peg drilling cycle, it is used for deep drilling. 84 right hand tapping. 85 boring or reaming cycle. 86 boring cycle. 87 back boring cycle. 75 74 left hand tapping cycle, and 76 fine boring cycle. And so these things, these cycles or these codes are all are for can cycle. Also, G98 and 99, the plane of the return point. So you might have studied this. G98 is called for subroutine, and G99 is called for or end of for the subroutine. So here the same codes we are using, but if they are used with these can cycle codes, their points will be, or their what the information conveyed by them is different. When the tool gets to the bottom of the hole and it can return back to the plane of R point and initialize plane, initialized by G98 and 99. Generally speaking, G99 is used in the first drilling plane, while G98 is use G99 for drill. Now I'll explain it with the help of this diagram. So this is the first drilling cycle, G81, simplest one drilling cycle. The code is G81 XYZ. XYZ indicates the location of the point where you have to drill. R is the radius, F is feed rate of cutting. R is the starting point and raising point, not radius, it's raising point. And K is the number of replication. Number of replications mean how many replications you need. So this is initial point. Now your tool is starting from this point. Dashed line indicates non-cutting motion, and when the tool is rotating, and dark line indicates your feed. That means your tool is rotating. Here dash line means not rotating, continuous line means rotating. Now first you start your point from this point, initial point. Then it will rapidly travel, the drill bit will rapidly travel up to this point without rotation. This is called as R point, reference point. We had discussed this before. Reference point, this is a safe height. From this point the tool start rotating and the feed is given. Now the hole is started drilling up to this point. Fine. After that, once the hole is drilled, the tool is stopped rotating. It is retracted to the safe point, and then it is moved to the next point. Again the same procedure. Now you can see over here, the tool is retracted to the initial point. sorry, reference point. Here the tool is retracted to the reference point. So if we are using G99 and number of holes need to be drilled, you will be using G99. That means your drill bit is retracted up to reference point. If you are using G98, your tool will be retracted to the initial point. See the dashed lines. See this dashed line. It is your tool is retracted to the initial point. Okay, so there are 2 points which are, first one is initial point and reference point. If you have to number of holes you need to drill at that particular time, you need not to call every time the drill bit at initial point. But what happens, because if you keep on calling it, the tool has to travel this much of distance more. This much more distance the tool needs to travel, and the time taken by the tool is also included into that. So if you have to drill 100 of holes, and for each travel from reference point to initial point, you will be use it will require 1 second. So you need to 100 seconds you will be uh, using more for drilling the 100 holes. So 100-second time is the non-productive time for in that particular case. So that's why it is advisable, or the programmer generally use to call the drill bit or the tool at some safe height or reference point, and then it moves to the another position. So this is the line block for the drilling cycle. So G81, XYZ, XY, that means it indicates your coordinates. R means starting point or raising point per time. It is in absolute coordinates. F is feed rate of cutting, how much is the feed rate, and number of replication. Like you have to repeat this G81 for 10 holes or 10 times. So every time what is only going to change, x and y and z coordinates are going to change. X, y and z coordinates are going to change, and rest of the things will remain constant. You need not to give the feed every time, you need not to give the numbers every time. Just you have to direct the tool where it has to drill the hole. So that is what we call as uh, drilling cycle, the can cycle. Every time it is called as can cycle. Then counter bore cycle, the same thing. Now for each and every cycle there are two codes, G98 and G99. 98 we call the tool at initial point, and G99 we call the tool as reference point. Now in what is the difference? XY data for hole site, Z is the depth of bottom of the hole uh, along Z direction. R is safe height. P is pause time. Now here we are using the dwell counter boring cycle. We are using the dwell. So how much time the tool needs to stop there over here is we have to calculate it, because in counter boring the tool starts rotating. It is if it is going to drill a hole in clockwise direction, if the drill bit is moving in clockwise direction, then at the time of retracting it is moving in counterclockwise direction. So that's why it is called counter bore type. So that's why to change the direction of rotation from rotating to clockwise to counterclockwise, there is some pause time. Okay, there is some pause time, and that pause time is commanded with the help of dwell command. So these are the can cycle. So what we had discussed so far, we had discussed about some important commands of CNC programming, and in next lecture we'll see some few more can cycle, and we'll solve few problems on the CNC programming. So I think that's enough for today. You can post your attendance in chat box and you can log off. Thank you.